welcome to another Reigate Further Maths video, this time on further mechanics, and we're going to be looking at successive collisions, just a couple more examples following on from the ones we did in the earlier video. So let's have a look at this example here. We've got two smooth walls, two vertical walls on a smooth horizontal table. They intersect at right angles and they're parallel with I and J. We've got a smooth sphere slides across the floor with a velocity of 6i minus 2j. So this is 6i minus 2j, this vector here. So it's coming in that direction. It hits one of the walls. It rebounds from the wall with a velocity of 6i plus j. So this is going to be 6i plus j. This velocity here, and it goes on to hit the second wall. The coefficient for both walls, the coefficient of restitution, is E. We've got to find the kinetic energy lost by the sphere in the collisions. So let's have a look and see what's happening. So if we look at the collision with wall 1, parallel to the wall, the velocity is unchanged, and we can see that because this is 6i and this is 6i. So we're going to look perpendicular to the wall. So for wall 1, looking perpendicular to the wall, we've got E multiplied by 2, that's the j component, must be equal to 1. That's the j component coming away from the wall. So E is equal to a half. So that gives me a piece of information I can use later on. Wall 2 collision. We just need to be careful here because for the second wall collision, we need to think which is the velocity perpendicular to the wall and which is the velocity parallel to the wall. So looking parallel to the wall is in the j direction. So that's going to be unchanged. So y is going to be equal to 1 if we call this xi plus yj. So y is equal to 1 because we are looking in the j direction and that is unchanged. So then we're going to look perpendicular to wall 2. So perpendicular to wall 2, we are looking in the I direction. So E multiplied by 6 is going to be equal to y. So we need to say E, which is a half, multiplied by 6 is equal to, now we need to be a little bit careful here because y is going to be negative, isn't it? Y is going to be coming out in this direction. So we actually need to say that a half times 6 is going to give me the x component, but it's going to be in this negative direction. So we're going to end up with a negative. I'll probably put the negative in here. Got to consider the direction there. So x is equal to minus 3. So the final velocity will be minus 3i plus j. And it's worth just checking when you do this that what you've got makes sense. So if you had a positive number of i's, you know that's wrong because it's coming back from the wall. So just think about whether your answer makes sense once you get there. So then the question asks, what's the kinetic energy lost? So let's have a look at that. Kinetic energy lost is going to be a half mv squared for its final, its initial velocity, which is 6 squared plus 2 squared, minus a half multiplied by m multiplied by 3 squared plus 1 squared for its final velocity, and that gives a half m times 30. So that is 15m. don't think we have been given the value of m. No, so we're just going to leave our answer in terms of m. Part B, the total angle through which the sphere is deflected in the motion. Well, it comes in at 6i minus 2j, and it comes out with this velocity here of minus 3i plus j. It actually is parallel. This vector here is parallel to the incoming vector, and we know that will happen if both of these values are e. But we ought to show it, so I would actually do for part B, use the dot product to say minus 3, 1, dot 6 minus 2 is equal to minus 18 minus 2, which is minus 20. And then I'd work out the modulus of each of these. So I've got minus 20 is equal to square root of 10 times the square root of 40 times the cos of theta. So I get from that that cos of theta is equal to minus 1, and that gives me theta is 180 degrees. So that's what we would expect it to be. I think you could probably just write that down from these two vectors, but it doesn't do any harm to show that little bit of working out. Right, let's move on to an example where the two walls are not at right angles, and they do ask these quite often. So you need to be able to manage this. So you need a really large clear diagram where you can mark in all the velocities very clearly and think about what your angles are. So we've got the two walls like this, and this is 30 degrees between the two walls. This one, the particle comes in, first of all, at a speed of u, and we've got an angle here of alpha, and we know that tan alpha is 4/3. So that gives me cos alpha is 3/5, and it also gives me sine alpha is 4/5. The coefficient of restitution between each wall and the particle is 3/4, so E is 3/4. I'll write that down here as well. And we've got to find the speed of the particle after one impact with each wall. So let's just start off and see what's happening. I would call this V and call this angle beta. I might wait to label this part of the diagram until I've done some calculations here to see what is going on. So let's start off parallel to wall 1. This is wall 1 here. So parallel to wall 1, we've got U cos alpha equals V cos beta. And at right angles to wall 1, we've got 3/4 U sine alpha equals V sine beta. So if I combine these here by dividing, I'm going to get, the U's are going to cancel out, so I'm going to get 3/4 tan alpha equals tan of beta. That gives me that tan beta is 3/4 times tan alpha, which is 4/3. So tan beta is 1, so beta is 45 degrees. So that's an important piece of information. Right, we now need to look back at the diagram and see what other angles we can put in. This angle we've now worked out is 45 degrees. Look at this triangle here. This is 45 and this is 30. So that makes 75. So this angle here is 105 and this angle is 75 degrees. Very important you get that correct. So just check your addition another time. So now we're going to look along wall 2. And if I look parallel to wall 2, I've got V cos 75 must be equal to, now I'm going to call that angle there gamma, and we will call its exit velocity W. So it is equal to W cos gamma. Then perpendicular to wall 2, I've got the E, which is 3/4 sine of 75 is equal to W sine of gamma. I'm interested in finding the speed. So I want to find W, so I'm going to square and add these two equations. So from that, I'm going to get W squared on cos squared plus sine squared gamma. I'm not going to write that little bit out because we know that's going to be equal to 1, is equal to V squared cos squared 75 plus 9/16 sine squared of 75. Should have been a V in there, I beg your pardon. So V in that equation as well. So we now need to substitute in, we need to find out what V is equal to going back up here. So if we look at these equations here, we've got that V squared from up in this equation here, V squared is equal to 2 times 9/25 U squared. That's squaring and adding these two equations to find out what V squared is equal to. So I would have U squared times cos squared of alpha, 3/4 times U squared sine squared of alpha gives me this equation here. So I now know what V squared is. So substituting into here, I get that W squared is equal to, I'm going to take this V squared out from this equation. So I've got V squared, which is 18/25 U squared, on cos squared 75 plus 9/16 sine squared 75. And when you put that into your calculator, you're going to get that W squared is 18 U squared over 25 on 50 minus 7√3 over 64. And that is equal to, actually, let's write it underneath, W is then equal to 0.653 U. So you could be asked to show it exactly, in which case you need to go with exact values, or you could be asked to give it to 3 decimal places or 3 significant figures. So there's either option there. But the important thing with this sort of question is to be very clear at each stage what it is you're doing, because you've got a lot of little equations that you've got to combine to get your final answer. So you need a large clear diagram, you need to work steadily and carefully, making sure that you've got the correct terms each time. You really need to take care of these questions, otherwise it's a bit too easy to make a slip that is costly later on. So that's a successive collision question where the wall is at an angle, and you need to go away and practice some of those now.